So today we'll talk about the loops and also again the machine cycles. In the last class we talked about the machine cycles, and we tried to calculate the machine cycles for some simple instructions and also with instructions with the pseudo op. So today we'll pretty much revisit the similar concept for the loop. So let's say here, if you look at these couple of lines, there are only like 3 lines, and all the lines we just have written is pretty straight, because the first line we are clearing the accumulator A, in the second line we are decrementing accumulator A, in the third line we have a branch. Now if you look at this branch, I'm sure you have seen this branch for many times, already you have seen it. This is it's an unconditional branch which branch without any condition. That means no matter what happens, this will branch. Okay. Now, can anyone here tell me how many times these loops will be running? If you look at this carefully, if you go to line 3, it's actually going back to line 2, right? Because of the branching, because it's like a negative branch, which is pretty much like a loop, right? Because it keeps coming to the line 3 and then going back to line 2. Keeps coming line 3, going back to line 2. If you look at carefully, these 3 lines of code, and then the first line is just one time, and then second line, third line, it goes back to second line, again third line, goes back to second line, again third line. These loops never stops. It will run forever. That means if you by accident write these lines in your program will never end. Never. I'm saying as long as your computer is turned on, it will never stop. Now, so think about the programs. I'm saying it can be extremely dangerous, because you probably looped something accidentally like this, and then it will actually keep running. So this is called infinite loop, which actually never stops. Now let me show you some other interesting loops, and then try to see whether we can understand how many times the loops are running. Okay. So let's look at these 3 lines of code, and in this code you will see your program is running, and in the starting with the first line and the second line and the third line, but when you go to the third line there is a branch. Now this is a conditional branch. That means if this branch makes, the new program will actually go back to line 2, right? Which is actually like a loop, right? Because you're going back. Now, the good news is this is a conditional branch. That means it might make, might not. But if it makes, it might make now, or it might not make next time, right? So we can tell exactly how many times it's making, and then going back, and at some point it will not go back. So we can just tell, oh, okay, this many times the program runs. Okay. Before I start, and talking and then explaining how the loop will be running, I just want to give you like a couple of minutes so that you can see and think and try to figure out how many times this loop may be running, just as a guess, because we already know about the branches, and we know that B&E is a branch, which is a conditional branch, and all the conditional branch has a condition, right, which we can find in our instruction set. And then we can just calculate it based on the flags, and we can tell and then guess some idea. But just let's see whether we can figure it out, and then we'll go over these and we'll figure this out. So let's see whether we can figure this out, that how many times this loop is running. Now before we start, you have to understand that the line 1 is actually not part of the loop, right? Because the line 1 is running only for one time, and then you are going to line 2 and then line 3, but if the branch makes, you are going actually back to line 2. So basically the part of the loop is the green lines, like the last 2 lines of the program, because which has a chance to keep going back and forth and then keep running, right? So let's see what happens in the first iteration, which is iteration 1. We actually will be trying to calculate the iteration, right? In the first iteration, what happens? Your accumulator A has a content which is 04, right? Because you loaded 04, I'm saying it's actually 05 at the beginning, and then you did a subtraction in the line 2 So by the time you hit line 3, when the condition is checked for the branch, your accumulator A is 0, 4, right? And then, if you recall, the condition for the BNE is Z is 0. So that means you will be checking whether the flag Z equals to 0, right? And you know that the flag Z becomes 0 only when your answer is 0 for the operation, for the last operation, meaning in this case for the subtraction. Okay. Now this time the test condition test condition. I'm sorry. The is become 0 when the flag is not 0. I'm sorry. Yeah. So this time the test condition met because the answer is not 0, right? So the 0 flag is not set. 0 flag is clear. So your program will actually go back to the line 2, right? And then let's look at the iteration 2. Iteration 2 again, your accumulator A is decremented by 1 again, right? Then your accumulator A has a new content which is 3, 0, 3. Still this is not 0, so the 0 flag is not set. So the branch will make one more time, right? Let's try that. So in the iteration 3, your accumulator becomes, A becomes 0, 2. It will make it once again, right? So in iteration 4, your accumulator is subtracted by 1, by 1 once again. So it's still 0, 1. So the branch condition made, and then it will go back to the line number 2 once again. In the iteration 5, what happens? Your accumulator A is 0, okay? And then this time is 0 flag is set, right? And then now if the program goes to the line number 3, it will never go back to the line number 2, right? Because the branch will not make anymore, right? So this was actually the last time your branch made. So basically, this is the last iteration, which is iteration number 5. So that your answer is just 5. So in pause, we'll give you something like this, similar, okay? So you actually have to play around play with the code, and then tell us how many times the program will be running, okay? And we'll look at a couple of more examples, because all the loops are not like this, but there are plenty of different variants of things. Let's see whether we can understand another one, okay? Now here is another one. As you can see in the first line, we are loading something into accumulator D, but we are subtracting from B in the second line, subtracting 1, and then we are going to the third line where we have a branch instruction. And again, as you can see here, only the line 2 and line 3 are part of the loop, because the program, if the branch makes in line 3, it actually goes back to line 2. So basically loop is only the last 2 lines, not the first line, right? So let's see what happens in the first iteration. In the first iteration, your accumulator B is actually 1. Why? Because think about this. You have actually loaded 0, 2 at the very beginning, okay, in the line 1. But by the time you ran line 2, your accumulator B is already decremented by 1, right, which becomes a 0, 1. And then you actually need 3 different flags to determine whether the branch makes, BGT makes, right? This is the test condition, Z flag plus within parentheses N exclusive or V. So we actually have to check all these 3 flags every time when we hit line number 3. In the first time, all these flags are 0. Why? Because the 0 flag is 0 because the answer is not 0. Answer is 0, 1, which is not negative as well. So the negative flag is clear as well. And the V flag is also clear if you check, okay, with our conditions. But the V flag. Now, since all these flags are 0, do you think the condition makes? Do the condition makes? So all these flags are 0, so the test condition met in the line number 3, right? Now remember, whenever the test condition makes, your program goes back to the line 2, right? So the program will go back to the line number 2 again. So in the second iteration, what happens? You decrement B by 1. Now the B becomes 0 and the 0 flag is set. All other flags like N flag and V flag are still 0. But if you check the test condition, but this time the test condition will not make because the test condition becomes 1, which is not equal to 0. So that's not true. So this is actually the last time your program ran. I'm saying your branch made, like BGT made, right? So the program, the loops delta will actually run for only 2 times. Any question? All right, so let's try another loop because we'll try some, interesting loops and see whether we can understand and figure out how many times the loop runs. So here the loop is, defined by loop starts with a label drop. So let's see how many times this loop label drop run. Okay. Now in the first line we are loading something, loading FFFA into accumulator D, right? And then every time we are actually adding 3 in decimal with the content of D, and then there is a branch in the third line which is BHI. So all you have to do is just check and see how many times the loop runs. In the first iteration, what happens? Your accumulator D had FFFA, right? And then you are adding 3, and that becomes FFFD, right? By the time you hit line number 3, you have FFFD in accumulator D. Now the BHI has a testing condition which includes carry flag and Z flag. So we have to check whether the carry flag and Z flag, what is the status. So the carry flag is 0, 0 flag is 0, okay? So that means C plus Z equals to 0, which means the branch makes, right? This time, because the carry flag makes. So the second iteration, what happens? Look at the second iteration, what happens? You are again adding 3 with the content of D, right? What is the content of D? FFFD, right? And you are adding 3 one more time. Now look at this, what happens? This actually becomes overflows, right? Because you have 1 followed by 4 zeros, and this 1 becomes carry, right? Because it cannot accommodate more than 2 byte. Now your answer becomes more than 2 byte, so the carry flag is set and the 0 flag is set as well. That means 0 flag is set because your answer is actually 0. So basically, the test condition will not make this time. So that means this was the last iteration when the branch made, right? So your answer is actually 2. So you loop drop ran only for 2 times, right? Any question?
So if you did 0, it drops.
See, the drop is just a label.
Oh yeah.
Yeah, yeah. Yeah, you stop the process. Yeah, all you need to see in all of this, the loops. All that we wanted to know from you is, can you tell how many times the loop is making? Okay, and this is pretty interesting because you have seen loops in the high-level language, but you have seen many different loops. Let's say in C++. C++ has a couple of different variants, right? Because you have for loop, you have while loop, you have do while loop. These are the primarily 3 different branches. But in the low-level language, everything is done in terms of branches, like branch instructions, okay? Now, so far what we have seen is something pretty similar like do-while loop, because think about the do-while loop. The do-while loop in C++ always runs 1 time no matter what happens, right? Because before the testing condition, you check, you already run 1 time and then you check, right? But again, you can do every other thing that you do in the high-level language just using the branches. Since we are just the beginner, so I just wanted to start with some very basic and simple ones. So we have the following 3 quizzes. We'll practice the branches. In all of these branch questions, we'll give you some branch, okay, couple of lines, and you actually have to tell how many times the branch will be running, okay? Now, in addition to the branch, since we started branching, we also want to see the runtime of the branches. Remember in the last class we talked about the machine cycles, and then later on we use the machine cycles to calculate the runtime of a block of code, right? Now we'll do the same thing for the branches. If you recall, this was the first branch we just discussed, right? This was the first branch, and then we figured it out that the loop actually will run for 5 times, right? Can you identify this code? Like, remember, we found that this loop runs for 5 times. Now, what does it mean? That if you try to calculate the machine cycles, think about the machine cycles. The first line is actually not part of the loop, right? So that has only 2 cycles, and that is fine. The second line has 2 cycles, but this is part of the loop, so the line will be running actually for 5 times, right? So basically that makes it 10 cycles. And the third line is part of the loop, which will be running for 3 times. I'm saying the 5 times and then 3 cycles each time, so it makes it like 15 cycles. So that means, see, we're still pretty much doing the same thing. The only difference is, to calculate the machine cycles, you will have to know that how many times the loop is running. Otherwise, you can't tell what will be the total machine cycles. Now, once you know the total cycles, let's say here we calculated the total cycles, which is 27 cycles. Now, given these 27 cycles, can we tell how much time we need to run these cycles given a microprocessor speed of 4 megahertz? We can definitely tell using our formula. Remember, we have a small formula for the runtime, which is done by total machine cycles divided by processing speed, right? We looked at that formula last class. So it's very simple. All you have to do is just 27 divided by 4 megahertz. In this case, 4 times 10 to the 6, right? So, once you calculate it, you can convert it back to the micro. Because remember, in pause, in most of the question, we already mentioned that, okay, write the answer in microsecond, or write the answer in nanosecond, or write the answer in picosecond. So we already mentioned. So you don't have to write the unit, but make sure you read the question. If you see the unit, you convert it back to that unit and then write the answer, okay? So in this case, we already converted. We converted to the microsecond, okay? And I'm sure that you all know about the engineering prefixes, right? Okay, now let's try and see how we can do it in our quiz section. In the following 2 quizzes, we'll pretty much do the same thing, but on top of calculating the machine, the loop, that how many times the loop is running, we'll also take a look at the machine cycles and runtime. But be careful about the one thing. If we miss how many times the loop is running, every following answer will be wrong, right? Because if by mistake we find out a wrong number of times the loop is running, your machine cycles will be wrong, your runtime will be wrong, okay? It's like pretty much, in sequence. So let me stop this presentation here so that we can try these quizzes, where we'll learn about the loops, machine cycles, and also the runtime involving the code for the code involving loops.